Good afternoon, everyone, and welcome to our webinar, System Transformation in the Offshore Renewable Supply. I'm delighted to see today the engaged and diverse participants in this webinar, and I hope you find this topic as fascinating and impactful as I do. So now I am going to start introducing our esteemed speakers, and I will give an outline of the structure of the webinar. Today we have Max Hawin. He is the lead of hybrid system modeling at TNO, and we have as well Noelia Gregorio Martin. She is a market analyst at TNO as well. And we have an external guest that he will join us for the presentation of today, Mark Bonenshascher, Managing Director of Eindhoven Institute for Renewable Energy Systems, and myself, Irache González, Program Manager of System Transformation TNO. The outline of this webinar, I will start introducing the transformation of offshore renewable supply, how we are shifting from the traditional wind farms to offshore energy areas. Later on, Max will present about the operational and economical benefits of offshore energy areas. And later on, Noelia will focus on the impact of the business case under the market reform. At the end, Mark will explain the system integration challenges and mainly focus on the global perspective. And the last 15-20 minutes, there will be room for a panel discussion and questions from you, from the audience. How to make interactive this webinar and how this works? If you have questions, please write the questions by using the button below at the right bottom in the video screen. We will try to answer most of the questions, but the ones that are not covered, please, we will answer them afterwards. And the webinar can be as well watched on demand at tno.nl. This is a series of webinars that we started in 2022 with the offshore wind under pressure, by 2030, the Switch laboratory, and several use cases. And since the last ones were so successful and we had so good feedback from the audience, this time we are going to have a second session in person on the 21st of November in Amsterdam, Sloterdijk, in the Aristo Center. So if you are interested in following up this session, or you want as well to have a joint collaboration, further discussion, please click in the screen that you are interested. We have prepared as well a case for discussing the next tenders, the offshore wind tenders of IMAUD Fergamma, but I would like also to keep it open based on the question and the feedback from you today. Okay, so now that we have outlined the webinar and we have introduced to our speakers, I will start with the content. And as most of you know, the current energy system, it is dominated by natural gas. Most of the renewable electricity sources are wind and solar in the Netherlands. However, by 2050, the wind capacity is set to become the dominant source of power, and it is expected to supply at least 70% of the electricity nations. That means that the offshore wind need to increase fourfold by 2030 and 3 more times by 2050. In the case of solar, it needs to increase by 2.5 more times by 2030. To reach these ambitious goals, the Dutch government issues annual tenders of offshore wind projects, supplying a continuous pipeline of offshore deployment opportunities. You can see in the graph here that since 2006, the first tenders were focused mainly on offshore wind deployment and upscaling. Since 2020, the system integration aspect were introduced in the offshore wind tenders. You can see, for example, the example of the Crosswind, the joint venture between Shell and NECO, and as well the Orange Wind project, that it has a huge knowledge platform for innovation, and they are investigating as well different concepts of subsea batteries together with floating solar and also hydrogen. And the next one is estimated to be at the next one, Nederbike and IMAUD Fergamma, is estimated to have as well the integration aspect. However, to unlock the full potential of the offshore wind, the offshore hydrogen production is also necessary. We see that by 2030, the surplus of electricity will be provided by coming from wind will be provided by hydrogen production in the coast. And also, it has as well 2 demonstration plant projects. The demonstration 1 project, it's wind to hydrogen in late 2029, and the second demonstration project, wind to hydrogen, of 500 megawatt hydrogen and 700 megawatt wind farm, estimated by the earliest 2030s. Post 2030, it is expected that the large offshore wind clusters are equipped with offshore energy areas, not only with offshore wind farm, but also with floating solar, with hydrogen, with storage, and it is estimated between 10 and 12 gigawatt of offshore hydrogen. So we are seeing these trends, and we see that we are transforming the traditional wind farms with wind turbines with the integration of the wind farms with floating solar, hydrogen, as well as storage, and the connection with the grid. And it is extremely important to align as well with the onshore grid system to avoid as well congestion and provide flexibility options. So for this, innovations are crucial to mature and de-risk the offshore hybrid systems. And for that, TNO is supporting the industry to move forward this transition. And now I want to give the word to Max to explain first how on these offshore hybrid areas can operate and can optimize their operational strategies by making revenue on different markets. Thank you, Max.
Thank you very much, Ratje, and good afternoon, everyone. Let me move on to this slide immediately. Today, we're discussing a lot about offshore energy areas, and we mean with that areas where we produce not just offshore wind, as we've done traditionally, but we start integrating also these other sources, as Ratje just mentioned. And for these areas, we often talk about integrating with not just the renewable side, the renewable generation side, but also the storage and conversion side. And then we often mention hybrid power plants. For these hybrid power plants, we have the renewable generation, so wind and solar, for example, but we start adding, for example, battery assets or hydrogen generation by means of electrolyzers, for example. And we do this mainly because we think it's interesting because of the advantages that we offer, that we are offered by means of cable pooling. By starting cable pooling on this local system, we can increase the utilization of the export cable that we have available. And we start also increasing the self-consumption of the plant as a whole by, for example, locally producing hydrogen. By doing this, we can start and also looking at, okay, we have more space available on this cable because we make better use of it. And that means we can also start increasing the installed capacity that we have available within the power plant as a whole. So for example, you'll see in a later case study that we can start oversizing based on the export cable that we have available. But the main thing we want to show you today is that by starting with these flexibility assets on top of the traditional renewable generation assets, we can start unlocking also the more energy products and more capacity products beyond what we traditionally look at, which is usually the day-ahead electricity market. So we talk a lot about these markets and these different markets that we want to operate on. And that's why we also usually dub it the multi-market participation, multi-market bidding with these hybrid power plants. And we essentially try to operate these hybrid power plants as a single unit. So from the outside world, it would seem as if it is a single asset bidding on the electricity market. While internally, there would be some balancing going on, of course. The advantage of this is that we can start increasing the self-consumption and making sure that we more smoothen the peaks, so do some peak shaving, for example. And by that, we can also start minimizing grid tariffs. From industry, we already see that there's much advantages to the flexibility assets by themselves. So, for example, in the graph here, you can see the advantages that you could gain from starting to operate in the market with a battery storage system. And once you go to multiple of these markets, you can actually see significant increases in revenue. And we will come back to this, how this will work for the hybrid power plants that we have in mind. The markets themselves, there are a lot of them. We won't go into detail for all of them today, but the main ones we've been looking into at TNO at the moment are the frequency markets. So this is the containment reserve, but also the restoration reserve, including both the automatic and the manual restoration reserve. And then also the passive balancing. And the focus for today, the example case that we will show, is mostly the FRR market, specifically the automatic frequency restoration market, and also the passive balancing markets. And the setup of this system is very similar to the schematic that you just saw. So we start with this hybrid power plant that we often discuss. And what we look at is doing forecasting, first of all. We start with forecasting, for example, of the generated power that we can expect. So this can be wind and solar. But we also look at market prices already. So this can be the day-ahead market in the traditional case, for example. But we also start adding different products to that. So, for example, hydrogen. Because we produce hydrogen, we also want to forecast what the price will be so we can take this into account when we do our optimization. And for the ancillary services for the frequency markets, for example, we also want to have a forecast of how much power do we expect to be reserved and how much do we think will actually be activated. And you will see a difference between those as well later on. From that, we take this data into account, and with the tools that we have within TNO, we start maximizing for profit for the operator. Looking at how we can ensure the maximum profitability of this system, of course subject to the physical constraints that we have. Very often this can be, for example, the export cable, but we can also have some operational constraints. So, for example, we can have an agreement in place where we need to deliver a certain amount of hydrogen each day. This is something we can also take into account. And the end result of this is that we will essentially have an output of the system that is a planning for the assets within the system. And from that we can learn how this system would behave and understand and support industry in the questions that they might have about such a system and implementing it in the real world. So an example that I wanted to show to you today is a relatively small megawatt scale hybrid power plant where we assume that we had a wind farm in place, for example, that has a certain export capacity. So as you can see, the wind farm and the grid connection capacity are matched in 22 megawatt. And then we start looking at, okay, what can we add on top of this? For example, here we've looked at adding almost twice the installed capacity of PV, some battery storage and some electrolyzer capacity. And we use some of the most recent data that we have available for the meteo conditions, but also for market data. And in this case, for simplicity's sake, we've assumed that there's a fixed hydrogen price to see how this would affect the operation of the power plant as a whole. And we start with forecast. So we look at what do we expect in terms of wind and PV generation. But of course, we look at the market prices and then also the operational conditions that would result from this. And then we move on to essentially the day before the day we're considering, where we do day-ahead optimization. We look at what the set points or the planning of this hybrid power plant would be. What would the power flows be? And of course, very important, what do we expect in terms of revenue from this hybrid power plant? And then finally, once we have this planning in place, we go to the day itself. And there we do real-time optimization. So we run the day as it is, and we see what the balancing requirements would be for this specific day. This can result, for example, from mismatches in what we predicted in terms of the power versus the real situation that we encountered there. So this is the setup for the case study that we've been looking into. And as a first result, what we noticed is that there is actually relatively limited curtailment that we can predict or expect from this additional solar that we're installing on top of the wind farm. Despite this undersized export capacity, we have significantly more rated power installed than the export cable can support. But we still see relatively limited curtailment for the case that we're considering. And on top of that, what we also see is that the utilization of the cable is actually a lot more spread out. So the average grid utilization, the export cable utilization, will actually go down compared to the case of wind, even of the case of wind only, but definitely of the case of wind and solar. And we see that there's a little bit of import starting, and this is because of the hydrogen production, of course. But this does indicate to us that there is actually space for more installed capacity in essentially the same system that we had before, simply because of the optimization and of the way we utilize the flexibility assets to make sure that we can make better use and more spread out use of the cable and of the generation of the renewable production. So I mentioned already this hydrogen production. We see that if we go to a multi-market situation, we start reducing the grid utilization even further. So we have even more spread out use of the cable, but this is in part also because we see that the self-consumption of the plant as a whole, and this in part also goes to hydrogen, actually increases. So this means that because we are on average making less use of the export cable, we could actually see this translate into a reduction in grid tariffs, which of course is very attractive for the operator. But on the other hand, we can also see that there is actually an increase in revenue. So if we look at the base case on the plot on the right here, you can see it in the light blue bar on the left. This is the day-ahead situation where we have simply added some hydrogen production as well. Once we start moving to the multi-market situation, the multi-market scenarios that we're considering right now, you can see that there is actually a significant increase from, first of all, the frequency restoration markets, where the capacity reserve has a significant share, but also the potential activation, which you can see in the empty bar on top. This also has a significant revenue component. And on top of that, you can also see that there is some increase in the hydrogen production that we expect. So there is some increase in the self-consumption of the plant to produce more hydrogen to deliver to the client that we have in mind for the same fixed price, mind you. And then lastly, all the way on the right, in the right plot, you can see that there is also a share there of the imbalance price. If taken into account, there is also revenue to be earned in the imbalance market. And this is, of course, something that can also relatively easily, with the flexibility assets that we have, can be implemented for the operator. That's just a very quick taste of what we've been working on within TNO. I'm sure there's more to discuss, but this is all from me for now. Please keep sending in your questions. But for now, I'm going to hand back to Iratxe because there's more to discuss today.
Thank you very much, Max. And it's very interesting to see how it's a win-win on these offshore hybrid systems, that there is a better utilization of the cable from the system side, and also the operator can also increase their revenues looking at different multi-markets. Yeah. Thank you very much, Max. Now, we look at how you can gain more revenues and also improve the export cables. But what happens if in a few years' time there is a market reform, how this business case can be impacted? So I will give the floor to Noelia. Good afternoon, Noelia, good afternoon. To also present what is the impact of the business case under a possible market reform.
Exactly. Thank you so much for the invitation and for Mark for his very interesting topic. And as Iratxe mentioned, what I'm going to be talking about a bit is how the business case for offshore wind can be affected if we see this type of market reform. And this is specifically relevant for offshore wind that is connected to hybrid projects. As you may know, hybrid projects combine offshore generation with the connection with different markets, different countries. And they're very beneficial because they allow us to increase our flexibility in the system while also decreasing our infrastructure costs. However, we see that there may be some problems regarding hybrid projects under our current market and our current regulatory framework. And I'm just going to use the example of the current market situation that we have of a normal offshore wind farm, for example, a Dutch offshore wind farm connected to the mainland in the Netherlands. And that connection is considered internal transmission, and that offshore wind farm will inject its generation to the Dutch market and will receive the electricity market from that. But when we add this additional element of an interconnection, things can get a little bit more complicated. If we add, in that example that I mentioned, a connection with, for example, Germany, the connection between the wind farm and the Netherlands now will have to compete for either the generation produced in the offshore wind farm towards the Netherlands or cross-zonal flows happening between Germany and Netherlands. This cable now is on hybrid assets and presents a problem when we consider the 70% cross-border trade availability rule that TSOs must adhere to since 2020. This rule basically says that 70% of the transmission capacity between two bidding zones must be available in order to produce cross-border trades. As you can see, under a current home market for hybrid projects, this will lead to market inefficiencies because we will see that in order to allow for these cross-border flows, we will see curtailment of the wind farm, which is not very efficient. To solve this, there's been a proposal of a new market design, which is the introduction of offshore bidding zones for these hybrid projects. These offshore bidding zones allow us not only to solve this problem with the conflict of the 70% cross-border rule, but it also has been seen improved to increase social welfare and increase market efficiency. However, there's a problem when we look at a challenge when we look from the perspective of the offshore wind developers, and this has to do with how the price is formed under these offshore bidding zones. In order to explain a little bit how this price formation works, I have here two examples, one with a low generation of wind, one with high generation of wind, but both will have the same outcome. If we see, for example, the left diagram, we will see a generation of the wind farm that will go towards the highest price zone of the two markets that is connected to. Any remaining availability of the cable will be filled by the cross-zonal flows from the cheapest zone to the high price zone. This will happen until we have fulfilled completely the capacity and we see a congestion. When a congestion happens, the offshore bidding zone will have the price of the next connected market which have not uncongested situation, in this case, the cheapest. We see this situation happening even if the bidding zone 1 would be the cheapest and the bidding zone 2 would be the highest price one, because the flows of electricity will always go from the cheapest to the lowest, always causing this congestion between the high price zone and the offshore bidding zone. As a result, we will see that the capture price that offshore wind generators will see under offshore bidding zone will be way lower than if they would be situated under a home market, and therefore could be detrimental for their business case. At TNO, we wanted to see how this price mechanism would work under a case study, and we took the Lion Link hybrid project. It's a hybrid project that will be expected to be operational after 2030, which connects the UK with the Netherlands through a Dutch wind farm. For this case, we wanted to see what could be the impact for the business case for this wind farm if we have an offshore bidding zone implemented compared to the current home market. And also we wanted to see what would be the consequence of adding a domestic demand in that offshore bidding zone. As you know, at the moment, when we have only UK or the Netherlands, for example, the demand of these markets will be the ones operating to affect how the offshore bidding zone will set its price. In order to do so, in order to assess the business case, we ran a power market model for the year 2030, and we are able to see the electricity prices for these bidding zones and see what the generation of the wind farm could be and derive what could be the business case. The results of this can be seen in these graphs that are showing at the moment. The upper figure shows the price duration curves for the Netherlands, the UK, and the offshore bidding zone. These price duration curves are simply the electricity price sorted from highest to lowest, and it gives an idea about the electricity profile for these countries and the offshore bidding zone. We see in orange that the Netherlands presents the highest electricity prices throughout the year, and the UK the lowest. Now, if you have followed a little bit what I explained before about how the offshore bidding zone set its price, you would have expected that the offshore bidding zone would follow the same profile as the UK with the cheapest prices. But we see that this is not the case. Actually, the offshore bidding zone is able to achieve higher prices through some hours of the year. And this can be explained if we look at the capacity of the transmission in the configuration in the picture below. We see that the UK has a connection of 1.8 gigawatts compared to the 2 gigawatt connection with the Netherlands. This causes that congestion may happen beforehand between the UK and the offshore bidding zone, liberating the cable from the Netherlands to the offshore bidding zone, and therefore being able to set the price with the Netherlands, which in this case has the highest price. If we look at the whole revenues perceived by this offshore wind farm in the two cases, we can see in the bottom graph that the offshore bidding zone would receive around 30% less revenues than the home market. However, it's important to notice that this loss of revenues for the generators is not a complete loss, but it must be understood as a redistribution of welfare, because these revenues of the generators are transformed into the congestion rents that are beneficial for the grid operators, the TCOs. This opens a debate on how wind farms could be, pay off or help through the redistribution of these extra benefits for the TCOs. If we add at the domestic demand that we mentioned before, in this case through an electrolyzer, we will see that when we add this electrolyzer, changes in the price formation on the offshore bidding zone can happen. We modeled this electrolyzer with a certain behavior. It has a willingness to pay. So if the electricity price of the offshore wind farm is above this willingness to pay, the electrolyzer will turn off. And if it's below, it will operate. The concept of why this electrolyzer is able to set a little bit higher prices under an offshore bidding zone when it's not compared to when it's not is because the additional demand in the offshore bidding zone can lead to congestion from the cheapest source, in this case the UK, again congesting this cable and setting the price of the Netherlands. This effect, however, is very marginal, as we can see in the bottom right figure, where only around 1% more revenue is perceived with this increase in electricity prices. But what is very interesting to point out is what is the benefit from the power to hydrogen perspective. If we can see in green that around doubles the revenue that the power to hydrogen would receive under an offshore bidding zone compared to a home market or if it would be situated onshore. And this is because it benefits from the lower electricity prices that is happening in the offshore bidding zone. This is a very simple case that we analyze, but however, as we move to more complex and more max offshore system with all the introduction of new technologies, as Irache and Max already mentioned, with the storage technology, more capacities for power to hydrogen, but also how the developments of the future onshore markets will happen as we move forward to the energy transition, will affect and introduce higher uncertainty for offshore wind developers under these hybrid projects. We see that there's some measures that can help to deal with this risk that offshore wind business can face under offshore bidding zones. And some of them are already being pushed through legislation, like, for example, the electricity market design reform is already stimulating long-term contracts, for example, power purchase agreements or contracts for difference, to help generators to hedge their risks regarding price or volumes. And these are considered one of the most suitable tools to help generators to deal with their business case. There's also other tools, for example, financing transmission rights and also compensation cost schemes that can help in case of inability of transmission capacities. But indeed, this is something that is still on the work, at least for the Netherlands, and that business cases for offshore wind will have to consider for assessing progress in tender process. This will be all for me for now.
Thank you very much, Noelia. And it is very interesting to see that under a potential market reform, the offshore wind business could have some challenges, but also the introduction of offshore hydrogen and also new market mechanism as the contract for diesel could also support and enhance the business case. So thank you very much. I'm seeing in my screen that there are coming a lot of questions. So I want also to mention here that tomorrow you will receive a link with the reports that support these two presentations. Today in the webinar, we wanted to give a voice over to the work that we have been doing, and it is a small part. So tomorrow you can download the report and look at all the assumptions, all the modeling, and all these conclusions, and I'll look more in detail. Before we go to Mark, I would like to ask Max one of the questions that are now in the screen. One of the questions is that the hybrid power plant is an exercise that you did, is a modeling exercise. Have you tested this in a laboratory environment?
Yeah, that's a very good question. You mentioned it briefly already that we've been working, well, with industry, of course, we've been talking with industry a lot to see if we can start implementing these tools. Because I think it's an interesting avenue to explore for them as well. So they want to start de-risking. But we're not sitting still ourselves. What we've been working on is what we call the Switch Field Lab.
Mm-hmm.
So we've been in collaboration with Wageningen University to start a field lab essentially in the middle of the country near Lelystad, where we're starting to combine wind and solar with battery and hydrogen assets. And there we're starting to test really these developments that and these innovations that we've been working on,
Mm-hmm.
making sure that we can provide the industry with sensible advice, of course validating the models that we have, but also warmly inviting industry, of course, to participate in this trajectory that we're on, and making sure that we can start de-risking these kind of technologies for their grand debut offshore, I would say.
Mm-hmm. Mm-hmm. Thank you very much, Max. Indeed, a great opportunity as well to show and present the Switch Laboratory. And this links with another question that I have. It's in the hybrid power plant, you propose a lot of installed PV power. So how to implement this at sea? I want also to refer to other project that we have is a Sense Hub, where we develop the implementation barriers that we have, and we demonstrate the floating solar in the sea, and we look at legal, ecological, and regulatory implications. Good. So there is another question for Noelia, and I will leave the rest of the questions and answer for later after Mark gives the presentation. The question, Noelia, is that what do you think it is that the offshore wind zone will happen in the future?
That's a very good question, and I think it's the $1,000,000 question. Indeed, I think from the very positioning of very relevant institutions such as TCOs, Acer, but also the European Commission have proved that the offshore wind zones is the best, more efficient way to carry out the market for hybrid projects. So I would expect indeed that there's something that will happen in the future. And actually, this is happening right now in Denmark.
Mm-hmm.
If I remember correctly, Denmark also has hybrid projects with Germany. One of them is the Bornholm Energy Island. And if I remember correctly, they are already on the process for declaring an offshore wind zone that will start at the same time that the operation of this energy island will happen.
Mm-hmm. Mm-hmm. Thank you very much, Noelia. So I guess that it is a matter of time that we are discussing this as well in the Netherlands.
Yes.
Well, thank you very much. I am going to give now the word to Mark, that will explain more on system integration aspects on the international perspective. Welcome, Mark.
Thank you, Iratxe. Thank you for the kind introduction, and thank you for the interesting presentation so far. I think the two reports that have been published by TNO highlight certain aspects in the system integration, and we will go into that in the next slides. So thanks for giving me the opportunity to present my perspective on the system transformation in the offshore renewable supply. And we will be talking about, indeed, from a more global perspective, both the price dynamics, also the speed. We were talking about when will things happen and what kind of implications will that have. So maybe to highlight the aspect of time, indeed, in this slide, that's the slide that I usually start all my presentations with. I would like to highlight the time that we have for the challenge of the energy transition. It's a very high over slide that shows in one view our global usage of primary energy consumption and how it's built up and how it has developed in the past 23 years. And as you can see here, our energy consumption is still consisting mainly out of fossil energy carriers, oil, coal, and gas. And only in these past 23 years, we see some stable consumption of hydropower. We see some consumption of nuclear that's actually phasing out, also due to the nuclear Ausstieg in Germany, and a slow but rapidly growing portion of green energy. And the challenge is, of course, that this time frame that we see here in this graph, this 23 years, that's exactly the time frame that we have set ourselves to make this energy transition happen. We have to have the energy transition happen by 2050. So that's not just a bit over 23 years from now. So we have to flip this chart. And I think that highlights that the business as usual approach is not good enough anymore. So we need to accelerate rapidly. And that means that we need a radical system change. We need to do stuff differently. And I think the 2 reports that were just presented give some pointers to how that could look like. So if we go to the next slide, I think we can see why, as the Netherlands, we should actually be maybe even more concerned than other Northwestern European countries about this fact. On the left, you will see the Netherlands as you normally do not see it. I purposely tilted this Google image where the north is pointing to the left. You can see that the Netherlands is really a delta area of large rivers flowing out of mainland Europe. And if you look on the height map on the right, you will see that, as most of the Dutch people actually know, a quarter of our land area is below sea level and half of it is not higher than 1 meter above sea level. So this means that we really need to speed up this energy transition because we are at risk both from floodings from the seaside as well as from the riverside, as we have seen so detrimentally 3 years ago in Germany and Belgium. And in the next slide, you can see a picture that was only of an event 1 month ago, where you can see the flooding in the central and east of Europe. So that's on the next slide. Yeah. So this was only taken 1 month ago. I think this is the risk that we as the Netherlands are facing. And this highlights the urgency of the transition that we need to make happen. Now, next to the climate change related risks, there is also geopolitical risks. And if we go to the next slide, we will see that as the Netherlands and actually as Europe in general, we have the problem that we are not self-sufficient in our energy supply. So we are a big time energy importer, and especially now that we have shut off the extraction of gas in the north of the Netherlands, we are even a bigger energy importer. And I think what we have seen in the crisis 2 years ago in the winter with the invasion of Ukraine, we had made ourselves as Europe way too dependent on a single supplier and a single source of energy import, Russian gas. And we have seen the detrimental effects of that on the market with prices that went through the roof. Now, we have been saved by the much condemned, actually, fracking gas from the US that we have imported in the form of LNG. And that has alleviated this crisis, but it brings a couple of other dependencies that we might not be so happy with. So what are our options? We can work on the reduction of our energy demand, and I think that's the first and the foremost thing that we should always look at. Then, of course, the increase of renewable energy production, and I think these offshore wind parks offer a good option for that. I will come back to that. We have to increase our energy import and diversify in suppliers and in energy carriers. And the last and the least desirable option would be to slow down the decline of fossil energy production. But in the end, we need to be able to power our industry, to power our society. Even though the penetration of renewables is so low yet on a global scale, below 10%, for the Netherlands a bit more, we already see that it brings a lot of dynamics, and we've been discussing that. So if we go to the next slide, I will highlight what my perception of that is. So there's a very simple problem with renewables that we all know, and that is that we tend to generate energy both in space and in time at the moment that we do not use it or where we do not use it. So we have a mismatch in time and in place. And the key challenge that we need to be working on is the transport and the conversion and the storage of energy, which we also take together and call system integration. And that's what we see here happening on these offshore wind parks on a single site. But we have to think about how we integrate these things in the larger energy system and what kind of dynamics that brings about. From an academic perspective, I think there's also a lot of devices that need to be developed where cost reduction is needed. Think about the electrolyzers where a lot of cost reduction is needed. The batteries where it's already happening. So these are the things that we are working on. This challenge is really big. If we go to the next slide, we will see the big importance of system integration. we are not handling this topic well at the moment, not well enough. And what we see, and you see here a nice overview from the Financial Times, is that this leads to negative negative price dynamics, where we have a negative price for electricity, and the amount of hours that actually happens in Europe has increased tremendously over the years. So you see that 2024, there was more hours with a negative electricity price than from 2019 to 2023 combined. And then the countries that are suffering most of that, you see on the right, it's Finland, it's Sweden with 4 different bidding zones, and it's the Netherlands. So this is partly for Sweden and Finland due to the hydro and the nuclear capacity that they have that are not so easy to switch on and off. And for us, I think it's due to this rapid penetration of renewables that we have seen in the past years. So how are we going to deal with this? If we are not able to deal with this in the right way, you can read in the Draghi report that just came out, 2 weeks ago, you can read that this will deter or slow the energy transition and deter investments. And that if you actually make that, add numbers to that, you can look up in the report of the International Energy Agency on the integration of solar and wind, that they predict that if we do not handle this well, that this will jeopardize up to 15% of the solar PV and wind power generation in 2030, which will in turn result in a 20% smaller reduction of the CO2 emissions in the power sector that we actually had anticipated by that time. So how does this look like, this system integration? So I've already highlighted the problem that we need to solve. So how will this new energy system look like? Well, there is in the next slide a very clear overview in one picture from the European Commission System Integration Working Group that highlights this. So on the left, I think you see the energy system as it is largely still now, where we have parallel energy systems for oil, for coal, for gas, and for electricity. And on the right, you see the dot on the horizon where we need to go. We need to go to a highly integrated energy system where there is no clear distinction anymore between producers and consumers. You can see that on the local scale, where you as a homeowner are sometimes a user of electricity and sometimes a producer if you have solar panels on your roof. But also here in these offshore wind parks, you can see this system integration within the wind park itself taking place at the moment that you add the electrolyzers to produce your hydrogen. So this will require a lot of devices that need to be built. It requires a system for energy storage and conversion that need to be made, that need to be integrated, but it also requires a different layout of our energy system and the trading that happens there. And on top of that, it requires an information system to actually steer this. So we will see the emergence of a sort of Internet of Energy to make this happen, because it will require a lot of rapid trading and rapid anticipation on actually the generation of renewable energy. So this, I think, is the dot on the horizon where we will go to. And if we look back again at the map of the Netherlands on the next slide, I think that the Netherlands is excellently positioned for this. So this Delta area, the Netherlands, has a strategic position to make this happen. Because of these rivers flowing out of mainland Europe, we are the gateway towards the central industrial sites in Germany. We have large industrial sites located next to our own harbors. So that provides a lot of opportunities for the import and the transit of renewable energy carriers. We have the gas roundabout underneath the Netherlands. That's also a strategic asset that we need to utilize. It also provides us with opportunities for the export of devices and knowledge for the energy transition. And then if we click one slide further, we will see that with the North Sea, we have a strategic asset for energy generation and trading. And I think that the development of these offshore wind parks and getting them as a separate bidding zone will accelerate that process. But I see some risks. So if we go one slide further, we will see that actually the rollout of offshore wind is stalling. It's not going fast enough. It's not fast enough for the targets that we've set ourselves. Earlier this year, the target of 21 gigawatt that we had set ourselves for 2030 was actually shifted 2 years later to 2032. And already earlier, the North Sea Wind Power Hub, that's a consortium of TenneT and Energinet, GasUnie and the Port of Rotterdam, already pointed out that the current rollout rate of offshore wind is insufficient to meet our Paris Agreement targets. And how does that come? What are the problems that they signal? Well, you can see that on the right. They point to a number of factors that are holding us back. So they point to problems in cross-border and cross-sector coupling and anticipatory investments for these activities. And I think that the studies of TNO that are just released actually show, they prove these points and actually show that I think the anticipatory investments is the main critical point. And this has to do with the legislation that needs an update. So the update that we will see, well, the update that we have already seen that enables cable pooling is a step in the right direction, I think. But the updates that we will still hopefully see soon for these offshore bidding zones, they pose an acceleration opportunity, but also a threat that was already pointed out by Noelia, because the business case for the offshore wind developer is undermined. And I think that the current forced separation between grid operators and energy producers actually hinders us at the moment in accelerating the energy transition, because it makes it impossible to redistribute the congestion rent income. That is the biggest income increase at the moment that you connect. You see here on the right that you connect the UK and the Netherlands via this offshore wind park, and it makes it impossible to redistribute that additional income to the wind farm developer. So we really have to think about how we organize the stuff in such a way that they can also profit of this, and that we can get back on track in the rollout of these offshore wind parks. Because in the meantime, if we don't, we are being overtaken by other parties. So if you look at the next slide, that's a very interesting slide that shows how fast actually the electrification is going at the moment in the world versus China. And you can see that China is really, really electrifying much faster than the EU and the US. And it's actually not just China, it's also Vietnam, Bangladesh, Korea. And they are at the moment spearheading the transition. I think the takeaway for me here is that incumbents are laggards, or in Dutch, we are facing the wet van de remmende voorsprong. Our lock-in in our current assets and in our current legislation make it very hard for us to accelerate this electrification. And maybe to illustrate it a little bit further, if we go one slide further, I would like to show what's been happening in China in the last years, where in the last, give or take 10 years, they have actually realized a lot of huge high voltage DC projects, also AC projects, where they are connecting the entire country. Just to highlight the most prestigious and the bottom one on the slide, they realized one project for 1.1 megavolts, so that's a 12 gigawatt capacity line for 3,300 kilometers, actually connecting the northwest with the southeast, with the large cities. That is resulted in a reduction of 38 million tons of CO2 emissions in China. And note that this distance is roughly half the distance from the border of China to the EU. So if you see, if you look on the picture on the right, you see that their ambitions reach further than China itself. And of course, things will slow down at the moment that you need to span multiple countries. But this is coming our way, and we need to be prepared. And just to give you an impression of the speed with which they managed to do it in their own country, this last project that I just mentioned was actually conceived between 2011, 2015, commissioned in 2015, building started the year after, and the first electricity ran through the cables in 2018. So in 3 years' time, they managed to deliver a project for 3,300 kilometers and a 12 gigawatt capacity. So this is the competition that we're up against, and this will come our way. So I think we have to up our game. We have to look critically at our legislation, at our business models, to see what we can do to actually accelerate the process. And again, I think the two reports that have just been released give some pointers for that. So I really hope that people will study that. Maybe then to wrap up in the last two slides, if we go one slide further, I hope to have shown you that in my mind, the energy transition requires a rapid acceleration, and that in turn requires a radical system change, both in legislation, in technology and technology integration. I think the key challenge is the transport, the conversion and the storage of energy, and that's what we need to focus on. So on system integration. And then in the next slide, I think that the Netherlands is strategically positioned to benefit from this transformation, but we really have to work on our regulatory framework and our market mechanisms to quickly scale up production and integration of renewable energy. So thank you for your attention.
Mark, thank you very much for this message and the outcomes of your presentation. I have a big list of questions, and the first one is going for Mark. Do you expect a change in the way we trade electricity energy in general? Will the merit order be supportive going to a more renewable energy system?
Yeah, I think so, because it has to. I think at the moment, the market is pushing us in that direction. What I am a bit concerned with, so now comes my personal opinion, is the focus that we have on the rollout of large-scale nuclear. So the plans that we at the moment have as a country to build 4 new nuclear plants, I think that will actually slow down this transition if we are not careful. So I know that this is a sensitive topic. I'm not against nuclear per se. If you have nuclear plants, don't shut them off, as we did in Germany. I think that doesn't help speeding up the transition. But here at the moment, I think the integration of renewables with wind, offshore, preferably, and with solar, I think that will result in a much faster cost reduction of renewable electricity than when we start realizing such large nuclear plants in the Netherlands, which will generate a lock-in on a higher energy price for the coming decades. So I think that the market will actually push us in the direction of cheaper electricity. Otherwise, we will see industry leave here. They are already complaining about the high electricity prices. So yeah, that will be my answer.
Mm-hmm. Oh, indeed, Mark. And another one that it is even with exclamation marks. We saw all the rotation of in Google Earth about the Netherlands to see the delta in Europe. How do you see to solve the lock-in we are in the Netherlands in Europe?
The lock-in that we have, I think there is you cannot completely solve the lock-in. We have a lock-in in an energy system at the moment that is already there. At the moment that we fix too much on the current earning models of the people owning those assets, then I'm worried. But I think with the push that we have seen for so-called renewable energy hubs and system integration on a local scale, I think we can actually utilize the existing infrastructure. So I am very much in favor of developing systems that can help connect different modalities of energy. So heat with electricity, with molecules. Smart electrolyzer setups, containerized, modular, so that you can quickly scale up the production thereof, so that you can result or generate a quick cost ramp down. I think that's the way to go for us, having the energy system that we have, and then connecting on certain nodes in these so-called energy hubs, connecting these different energy systems with each other. We might actually counter the incumbents are laggards argument and actually accelerate with the assets that we have.
Thank you very much, Mark. This gives a good link for the next question on the hybrid power systems. And then there are a few questions around the topic and say, will the security of supply increase?
This is a very good question, I think, because this is something we've been discussing as well internally, because it is a hot topic. Both on the hardware and the software side, I think. And what we see is that there is a possibility to increase the security of supply with these kind of systems, making sure that we have either redundancies or multiple sources of generation in general. But also, as Mark mentioned as well, these energy hubs that we go to, they are usually a lot more resilient because they are interconnected between each other. So in that sense, we can look towards, first of all, eliminating or reducing the intermittency of the renewable generation, but also looking at how we can use these energy hubs in a way that they are more interconnected and therefore more resilient towards either failures or at least ensuring that we have security of supply, increased security of supply.
Yeah, thank you very much, Max. And also you saw in the example of your case study that on the hybrid system, on having wind and solar and storage and hydrogen, we reduced the utilization of the export cable. We as well reduced the total curtailment, and we as well maximize the use of the cable, right? So
yes.
This is related as well with what Mark says, that we need to reuse as well the existing infrastructure.
Yeah, as much as we can, of course, because the infrastructure is getting a scarce resource, becoming a scarce resource.
Yeah, there is another question related to that, Max. The added value of batteries comes from the addition of solar. For wind only, the role of batteries due to the limited energy storage is limited. What's your view on that?
I think it can go both ways. It really depends. If we have the traditional configuration that we've seen so far for the tenders, where we have a export cable that is matched to the wind power, the wind rated power that's installed for the wind farms, of course there is a limited participation there for the battery system because we have enough capacity available to transport all the wind power. I think it is once we start upscaling or overplanting of whatever generation source we have available, then it really becomes interesting to look at these flexibility assets. And that is, of course, for the batteries, because we can start peak shaving, we can start time shifting. And I would say that this is more or less irrespective of what generation source you use. It's more making sure that we can start smoothing out this this generation that we have, reducing the intermittency, and getting closer to this ideal baseload generation that we ideally would all want to have.
And you are referring to the behind the meter, right, from the supply side?
Of course, yeah. There's of course an argument to be had that we also need batteries in the system, but their location will be critical to how effective they will be, because they might also contribute to the congestion problems if they're located in the wrong locations.
And on that topic, related to the revenue stacking, there is a question. Can you give some more context about the redistribution of revenue in case of offshore bidding zones? How the best incentivize developers to build these projects?
Yeah, I think this is a very good question, and there is a lot of uncertainty there, of course, as Noelia indicated as well. There's very high uncertainty in how these are going to develop in the future. This is something we are monitoring constantly, of course, and of course, with the market models that we have within TNO, we're aiming to also project and see how this would affect the operation of the hybrid power plants in collaboration with industry, of course.
Yeah, no, thank you, Max. Another question, and it is related now, making the bridge to the offshore bidding zones. There is a question about what happens if the UK link would have the same capacity as the Dutch?
Yes, that's a good question. So normally what we've seen in previous studies is that normally the connection will be symmetrical. So as an example that I gave in the beginning, the connection between the offshore bidding zone is the same for both connected markets. In that case, we may not see the increase in electricity prices of the offshore bidding zone, because this limited transmission is what produces the congestion happening between this. So then we wouldn't see this increase in the electricity price for the offshore bidding zone.
And it has some influence that, for example, the electricity prices in UK are lower than in the Netherlands due to the more renewable penetration there. Indeed.
For a model, the scenarios that we chose are for 2030. And as we know, the UK has a huge potential for wind offshore, which indeed produces this difference in prices, with UK presenting the lower electricity price in this case, and Netherlands presenting higher. But as I also mentioned, this could change as we move forward with a development, more integration for sun, for wind, these dynamics of prices can change.
Another is says about offshore bidding zones. Do you foresee one large bidding zone in the whole North Sea, or is it expected that it's going to be split into different offshore bidding zones?
That's a very good question. I don't see a huge offshore bidding happening, because then you will have to cover many projects in it. They will be really hard to manage, I would say. I think it would make more sense that offshore bidding zones will be given for certain hybrid projects connected to it, rather than having a whole offshore bidding zone in the North Sea for it. Yeah.
Thank you very much, Noelia. Well, going back as well, and again to Mark, and a bit abstracting towards the global perspective, I'm going to read a few sentences and then a question. The North Sea Wind Power Hub Pathway 2.0 study came to 40 gigawatt equivalent offshore electrolyzer capacity. This will require islands, but the recent report by Deloitte showed that there is, for the time being, no business case for these islands, as opposed to the platforms. Recently, Denmark canceled their planned island. How much electrolyzer power do you expect in 2050 for the Dutch part of the North Sea?
Okay, that is indeed that is a good question, and it's a tough question because it asks me to predict the future, which of course comes with all kinds of caveats. I dare not at the moment attach a hard number to that. I think the business case for electrolyzers is tough. What we see with the study that was just presented is that it improves with these offshore bidding zones, because you have more hours of cheap electricity available, because you link multiple markets on an island. So you can actually utilize cheaper electricity, and you can run more hours. You can run your electrolyzer more hours cost effectively. So that will help. So this will improve the business case. At the same time, we have to realize that the North Sea, it connects to, at the moment, countries which still have significant industry assets that also require power. So a lot of the, there will always be quite a high power price if you compare it with countries like, for example, Brazil, where you can lock in for 10 years on a 2.5 cents per kilowatt hour price. The business case for electrolysis becomes very different. And I think the uncertainty in the market that we're still facing at the moment also hinders the development or the rollout of large-scale electrolysis in the Netherlands or in Northwest Europe in general. That's not to say that there is not a business case for electrolysis. I think we do need electrolysis. I do think we do need electrolyzers, a larger scale manufacturing cost ramp down. And I think we can install that on various places on the world. And then once the capex reduces, and hopefully a bit more certainty is also in the market developments here, so that we can do better OPEX predictions, then you can also give a harder number to how much how much hydrogen production we will see here in Northwest Europe.
Thank you, Mark. I also want to highlight as well that to unlock the full deployment of wind energy, we also need as well offshore hydrogen. So it is not only a matter of cost reductions and where are we going to install the hydrogen, is that also to deploy all the renewable capacity, we need as well other type of energy carriers. I'm trying to go through all the questions, but I am afraid that we are not going to cover everything, so I'm going to repeat myself that after the webinar, we are going to do our best to come back to your questions. But still we have a bit of a time, so I continue. Curtailments are seen not only in large projects, but also in small residential solar. Until 2023, we had a huge growth of solar capacities, which significantly decreased this year due to curtailments and changes in energy policy. How can we in the Netherlands better use our already built renewable capacity, and when can we expect that to happen?
That's a question for me.
Yeah.
Yeah,
for Max.
I think, of course, we focused a lot on the offshore part, on the hybrid power plants, which are larger scale, megawatt scale, maybe even gigawatt scale. And there we see that there is more self-consumption, or making sure that we have a local generation hub, so to say. It is difficult to predict how this will go for the local neighborhoods, for example, within the Netherlands. But you could see, and this is also the research we're doing with Wageningen University, for example, that you could have local hubs where there is production and consumption of your own generated electricity, and maybe also to an extent hydrogen. In this case for Wageningen, there is an agricultural angle to this, of course. They are very interested in seeing how can we use our own energy in our own local agricultural system. But this could very well translate also to local neighborhoods where you can have energy generation that is also used locally with all the energy consumers that you can have, of course, within the neighborhood. This is, of course, a little bit predicting the future as well. But there is opportunity there, just as well as there is opportunity for the offshore areas, because they are not so dissimilar in their operation profiles, but also in the problems that they face right now.
Thank you very much, Max. I also remind me a discussion that we had previously with Mark about the onshore energy hubs. Maybe you want also to mention something there.
Yeah, I agree a lot with what Max just mentioned. So I think in the discussion about these onshore energy hubs and the integration of a battery, again, the question comes, where do you put the battery? Because you will have a tension between the business case for the battery and actually the resulting grid alleviation of grid congestion. So at the moment that you would simply roll out home batteries now on the local home scale, you will see maximal trading at the moment of peak power or peak demand, which will only add to the grid congestion. So only once you implement legislation in such a way that you really stimulate behind the meter usage, maximum behind the meter usage, I think that will help. And in the current market, well, the current market, in my opinion, is not ready for a large-scale stimulation of home batteries. So I think in that sense, we see indeed on a local scale, we see exactly the same discussions and the same dynamics as that we see here on a much larger scale in these offshore wind parks. And indeed, coming back to the electrolyzers, like you said, Iratxe, we do need them. We do need to complement the various technologies with forms of storage or conversion. But it seems that our market at the moment is not fully suited for that yet. And I think that is the big challenge, to look at how to make that happen in such a way that it is the best for the total system, and not only for a specific participant in that system.
Yeah, thank you very much, Mark. And now, moving towards, we saw that the operational strategies, best utilization of the export cable, different assets. We talked about the offshore bidding zones. You, at the latter stage on your presentation, Noelia, you mentioned about the future market mechanism. There is a question here, and I like it very much. Many UK offshore wind projects are under CFD, contracts for difference, with an hourly reference price. Could this hinder efficient use of the interconnection?
Oof, that's a very good question. In the sense that offshore wind farms will not bid strategically? This is the question with the contract for difference?
Maybe it is going a step back. Maybe you can explain a bit to the audience what is a contract for difference and how it works, and then maybe we can understand better.
Yes. So basically, a contract for difference, if it's state-backed contracts for difference with the government, it has a very similar behavior as a power purchase agreement would have. The parties agreed to strike price, in which the electricity price would be, the market electricity price could have over this strike price or lower this strike price. And basically this difference will be either paid by the generator back to the state, or the state will subsidize this difference back to the generator. The question about the UK, how these offshore wind farms will hinder the offshore...
Yeah, I would reformulate the question a bit simpler. So how could benefit to the Netherlands if we move towards a contract for different mechanism? Now we have the PPAs, the power purchase agreements. How do you see the contract for different mechanisms for the wind operators here?
Yes, I think it would really help to have a stable revenue because power purchase agreements are still not very developed. Unfortunately, the market for power purchase agreement is not that in place at the moment, and especially could be quite difficult on the offshore bidding zone because you have different market prices. So this will be more like cross-border PPAs, which is not very developed at the moment. So contracts for difference can have this backup help for the developers to assess better their business case and secure a revenue stack that may not be available if they only play with the market or only with the PPAs.
That this is what it is happening now that the offshore wind farm operates subsidy-free.
Exactly.
So that could be a kind of a support mechanism for the operators.
Exactly.
Thank you very much, Noelia. Well, I'm going to handle the last question about hybrid power plant systems, and we talk a lot about the existing infrastructure, and I would like to ask Max, is it possible to increase the voltage of the export cable?
This is a very good question, I think, because it comes up in discussion a lot, not just the voltage, but the capacity of the export cable in general. For a large part, this planning is already being made or has been made of what they will install in terms of export cable. I think it is something that we are closely monitoring because it's very much also something we look at towards TenneT, for example. There are possibilities there, of course, and it is a logical thing to look into, also with the difference going from HVAC to HVDC. This is a development that is already happening and will happen for the upcoming tenders. For the specific voltage levels, of course, that's not necessarily up to us to say anything about that. It's very much predicting the future. But there is, of course, an opportunity there to see, okay, can we also start laying out these cables in such a way that we have more either interconnection or more capacity in the cable itself. That's something that we're taking into account as well, of course.
Thank you very much, Max. Okay, so it's just almost finalizing the webinar. I want also to mention a couple of things. So the first thing is that all the questions that we couldn't cover in this hour and 15 minutes today, we are going to come back to you by email. We have as well the contact person who wrote the question, so we will come back to you. As well, I would like also to remind that there is a second session after this meeting on the 21st of November in Aristo, in Amsterdam, Sloterdijk, where we will meet in person to discuss, to follow up these topics. We also have prepared a discussion and a case over the next tender IJmuiden Vergamma. But as I said in the beginning, this is open. It is still open to see what is the participation of the second session and who wants to join. That is all for now, and I would like also to finalize the presentation. Thank you very much all, Mark, Noelia, and Max for presenting, as well all this fascinating audience that we had today. I hope that you learned as much as I did today. And also, I would like at the end, if you could fill in the poll that it is going to be after the finalization of this webinar. Well, thank you very much all.